Hello everybody, thank you for watching. This is our 7.7 video on molar mass. In this video, you're going to talk about molar mass and learn how to calculate the mass of a mole of any substance. So let's start by talking about what if we wanted to know how much 1 mole of sulfur atoms weigh, or if we wanted to know how much 1 mole of iron atoms weigh. Lastly, what if we also wanted to know how much 1 mole of carbon atoms and how much they actually weigh? If you take a look at this, each one of these squares come from the periodic table. The good thing is we know that a mole equals 6.02 times 10 to the 23rd things. So what we're asking is, out of all of these things, just 1 atom of sulfur, how much would it weigh? So if you take a look at the atomic mass on the periodic table, you can see sulfur actually has a mass of 32.06. Iron has a mass of 55.847, and carbon has a mass of 12.011. The good thing is that each one of these atomic masses equate to 1 mole of sulfur atoms. So when you take a look at sulfur, you can say that 1 mole of sulfur atoms, they weigh 32.06 grams per every 1 mole. Iron atoms, for every 1 mole of iron, they weigh 55.847 grams. And that number, that mass, just comes from the periodic table of elements. So when we're figuring out the mass of 1 mole of any type of atom, that is called the molar mass. The definition of molar mass is the mass of 1 mole of a substance found by expressing the atomic weight in grams. So when we take a look at our examples again of sulfur, iron, and carbon, we can say the molar mass of sulfur is 32.06 grams per every 1 mole. Iron has a molar mass of 55.847 grams per every 1 mole. And lastly, carbon has a molar mass of 12.011 grams per every 1 mole. So this is a new term to us, molar mass. So whenever we're saying that, we're talking about a mass per every 1 mole. So now, what if we wanted to calculate molar mass for atoms? For example, mercury is an atom. We want to calculate the molar mass of that. We can do that. What if we wanted to calculate the molar mass of a molecule? We know molecules are covalently bonded, so that's CH4. That's one example of a molecule. Or we can actually calculate molar mass of ionic formulas as well. The good thing is they all have the same steps. So let's take a look at some example problems. So if we wanted to calculate the molar mass of tin, we know it has an element symbol of Sn. All we need to do is look on the periodic table of elements and look for tin. If you take a look at it, tin has a molar mass of 118.710 grams per every 1 mole. So the molar mass of tin is just going to be the number that you see on the periodic table of elements. Let's take a look at another example. Here we have a molecule. We want to calculate the molar mass of C3H8O. So what we need to do is we need to look at all the elements that we have in this compound. We have carbon, hydrogen, and oxygen. So these are what the squares look like on the periodic table of elements. If you take a look at our formula, we have 3 carbons, 8 hydrogens, and only 1 oxygen. Therefore, we need to account for each of these masses. So, if we take a look at carbon, since we have 3 carbon atoms in this molecule, we can multiply the mass of carbon by 3. Since we have 8 hydrogens, we multiply the mass of hydrogen by 8. And since we only have 1 oxygen, we only need to write 1 oxygen. Then we're going to multiply everything across and get our answers. And in order to figure out our final molar mass of this entire compound, all we need to do now is just add up all these numbers. When you do that, you're going to get a molar mass of this molecule, C3H8O, as 60.087 grams per every 1 mole. So grams per mole is the unit for molar mass. Let's take a look at another example. Here we have an ionic compound. We have calcium, nitrogen, and oxygen. So if you take a look at each square on the periodic table, we have these 3 squares. This subscript 2 is going to be multiplied by oxygen, and it's going to be multiplied by our nitrogen, changing the number of atoms we have. So in this particular ionic formula, we only have 1 calcium, we have 2 nitrogens, and lastly, we have 6 oxygens. So why don't you pause the video and try to come up with the molar mass for this ionic compound. Hopefully when you did the mass and you calculated all of these different molar masses, you got a final answer of 164.034 grams per every 1 mole. Let's look at our last example. Here we have something called a hydrate. Right? We know it's a hydrate because there is some water attached to it. In this full compound, we have magnesium, sulfur, oxygen, here, and hydrogen. So therefore, we have 3 total atoms. But we have 1 atom of magnesium, we have a sulfur atom, we have 11 oxygens, and that comes from 4 here, and then 7 on that side. And we have 14, 7 times 2 is 14 hydrogens. So pause the video and try to get a total molar mass for this compound. When you multiply each of the atoms by its molar mass, you get a final molar mass of this entire hydrate as 246.367 grams per every mole. Now let's try some practice problems. This concludes our video for today. Thank you for watching.